So good evening all, welcome to SAKALAVIDYA YouTube channel. So once again I welcome to the evening session classes, and today we have one more class also that we need to continue even direction cosines and direction ratios also. So I will intimate the during time, I'll give the notification also. Okay, right, thank you. So the class will be continued up to 5 o'clock only today, right? So let me start first now. Okay, once again good evening all. Binomial theorem part 1. So this is actually, we can say that 2 to 3 marks, 2 or 3 questions may appear in the examination. Okay, Kuncham Sampath, right, Raghunath. Right, binomial theorem part 1 today. First, today we shall discuss some concepts. So tomorrow onwards and part 2 onwards we have the problems, we shall do the problems. Okay, first before going to the binomial theorem, let us discuss because actually even permutations and combinations also based on some introduction. So let me discuss some concepts, factorial concept, then I go for binomial theorem. So what is the factorial concept? Factorial, the concept of the factorial. The factorial symbol is like this. Okay, for example, if n is a positive integer or n is a integer either, positive integer, okay, then this n factorial is defined as n times n minus 1 factorial. This is n factorial, right? Good evening. So here we need to make agreement 0 factorial we need to consider as 1. That can be proved in permutation combinations, no doubt. So please remind me, I will prove 0 factorial is equal to 1 also. Leave it for a while. 0 factorial is equal to 1 you need to take. Next, now this n factorial means actually n into n minus 1, n minus 2 and n minus 3. That means starting from n you need to subtract 1 1 1 1 dash 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 3 into 2 into 1. This is actually the product of the first n natural numbers is n factorial. Okay, now n factorial is equal to n into n minus 1, n minus 2, n minus 3 and dash dash 3 into 2 factorial. So for example, now if you want to find out 1 factorial, what is 1 factorial? 1 factorial is equal to 1 into 0 factorial. 0 factorial is equal to 1, so 1. So what is 2 factorial? 2 factorial means 2 times 1 factorial. 1 factorial means 1, 2 into 1, 2. What is 3 factorial? 3 factorial means 3 into 3 minus 1, 2 factorial. That is 3 times 2 equal to 6. So now similarly 4 factorial. What is the 4 factorial? 4 into 3 factorial. 3 factorial means 6, 24. So similarly we can find out 5 factorial. 5 factorial is equal to 5 into 4 factorial. 4 factorial is 24. 5 into 24 is 120. What is 6 factorial? 6 into 5 factorial. That will be 720. Understood now? What is 7 factorial? 7 times 720. How much you will be getting? 0, 14, 50, 40. And like that 8 factorial, 9 factorial also we can find out. Very simple manner we can find out. So you remember this definition, n factorial definition. So next, now this is the factorial definition. So next, binomial theorem. Binomial theorem. In this binomial theorem, before going to discuss, first let us discuss NPR. What is the NPR? This is actually number of permutations. So number of permutations means n factorial upon n minus r factorial. This is NPR. So now second is NCR. This is combination, number of combinations. N factorial by n minus r factorial into r factorial. Otherwise we can write NCR by r factorial. Or we can write like this, r factorial, this is NP, sorry, 1 minute. NPR. See, r factorial is equal to, we can write NPR by NCR. This is a relation between permutations and combinations. And third point, see, you have NC naught. NC naught is equal to n, remember. Okay. Next, NC1. NC1 is, NC naught is 1. NC1 is n. NC2. NC2 is equal, generally we may use this formula, otherwise n times n minus 1 upon 2 factorial. That means 2 factorial means 2 into 1 right now. NC3. What is NC3? NC3 is equal to n into n minus 1 into n minus 2 upon 3 into 2 into 1. That is 3 factorial. Similarly, NC4. N times n minus 1, n minus 2 and n minus 3. 4 factors we have in the numerator. Here what we need to write? 4 into 3 into 2 into 1. This will be useful in binomial theorem also. Okay. Next, fourth concept. See, this NCR is equal to NC n minus R. Even it will be useful for permutations and combinations also. Those concepts also will be completed here. Now, see, NCR is equal to NC n minus n. That means, example, see, if you want to find out phi C3, this phi C3 is also equal to phi C phi minus 3. This is equal to phi C2. Phi C2 means, very simple, you can write 5 into reduce 1, 4 by 2 into 1. It will be 10. For example, if you want to find out 9C8, 9C8 is, you can write 9C 9 minus 8. It's equal to 9C1. 9C1 means 9. For example, if you want to find out 100C98, this is equal to 100C, 100 minus 98, 100C2. 100 into 99 upon 2, 2 into 50. Okay, 50, 50. So like this will be useful. Even sometimes, see, NCR is equal to NCS. Then R is equal to S, or N is equal to R plus S. N is equal to R plus S. Even you remember one more thing I have forgotten. NCN is also NC naught. That's equal to 1. Understood now? NCN equals to NC naught equals to 1. So one example let me discuss here. For example, NC5 is equal to NC3. What is N value? N is equal to, we can write 5 plus 3, that is equal to 8. Okay. So for example, NC7 is equal to NC8. Then N is equal to, that is 7 plus 8 is equal to 15. Okay, understood now? Okay. No, I don't teach any paid classes. I don't teach any paid classes. Okay. The sixth concept. This is very important. NCR upon NCR minus 1. This is n minus of r minus 1, n minus of r minus 1 by r. This is equal to n minus r plus 1 by r. For example, NCR plus 1 NCR. It's very simple, n minus r by r plus 1. NCR plus 2 by NCR plus 1. This is n minus r minus 1 by r plus 2. So this is very important, you remember. So generally during the problems actually we can apply this formula. Okay, now let me go to the directly now switch over to the binomial theorem. Binomial theorem. Binomial theorem. So this is the definition of the binomial theorem. See, if n is a positive integer, first let us discuss for positive integer. N is a positive integer, then x plus a whole to the power of n, x plus a whole to the power of n equals to, first we can write nc naught x to the power of n plus nc1 x to the power of n minus 1 a plus nc2 x to the power of n minus 2 a square plus dash dash ncr x to the power of n minus r a power r plus so on dash dash plus ncn a to the power of n. This also we can write sigma ncr x to the power of n minus r a to the power of r is equal to 0 to n. This is called binomial theorem for the positive integer n. Positive integer n. So this is the binomial theorem. So first here, how many number of terms? So let us discuss now concept. First important point, the number of terms. The number of terms in the expansion x plus a whole to the power of n is n plus 1. The number of terms is terms in x plus a whole to the power of n is n plus 1. Next, see here the sum of the powers of x and a in any term. Sum of the powers of x and a in any term. Let us check it now. So that means actually power is n. Here n minus 1 plus 1 n, n minus 2 plus 2 n, n minus r plus r n, n. That means the sum of the powers of x and a in x plus a whole to the power of n is n equal to the power of the binomial expansion. Okay. Next concept, nc0 comma nc1 comma nc2 comma nc3 and so on NCR dash dash NCN. Already we have discussed how to evaluate these values. Or we can say, simply we can write C0, C1, C2, C3, so on, CR dash dash CN are called binomial coefficients. Binomial coefficients. Binomial coefficients. Okay? Okay. Now let us see this NC0 is equal to NCN. Am I correct? We have discussed earlier. Similarly, NC1 is equal to NC minus N1. NC2 is equal to NC minus N minus 2. So NCR is equal to NCN minus R. So that means, so next point is the binomial coefficients. The binomial coefficients. The binomial coefficients. These are the binomial coefficients. Okay, binomial coefficients which are equidistant from beginning and end are equal. So that means NC not equals to NC1, NCN, NC1 equals to NCN minus 1, and so on. NCR equals to NCN minus R dash dash. They are equal. Okay. Okay, next, generally terms are denoted by T1, T2, T3 and so on, TR plus 1, so on, TN plus 1. Generally, here this TR plus 1 is called general term of the binomial expansion. So the TR plus 1 is equal to, you can remember like this, NCR x to the power of n minus r and a to the power of r. This is the general term of the binomial theorem. So with the help of the binomial theorem, general expansion, any term you can find out. For example, see, if you want to find out in x plus a whole to the power of n only. For example, if you want to find out T5, how to find out fifth term? This we can write T4 plus 1. So n C4 x to the power of n minus 4 and a to the power of 4. So what is T8? T8 is T7 plus 1 NC7 x to the power of n minus 7 and a power 7. So like this we can find out any term. Okay. right now. So one more important point you remember here. In the expansion, in x plus a whole to the power of n, rth term from end. If you want to find out rth term from end, rth term from end is equal to n minus r plus 2th term from beginning. So this is very important point to remember. Sometimes you may be asked to find out some 8th term from the end, 9th term from end, okay, like that. See, whenever you are asked, so you need to refer this concept. Okay, now let us move to next concept. See, x minus a whole to the power of n. Just we have discussed x plus a whole to the power of n. Now how to find out x minus a whole to the power of n? Simply in x plus a whole to the power of n, you put a for minus a. So this equals to nc naught x to the power of n minus nc1 x to the power of n minus 1 a plus nc2 x to the power of n minus 2 a square and plus so on dash dash minus 1 to the power of r ncr x to the power of n minus r a power r plus so on dash dash plus minus 1 to the power of n ncn here a to the power of n. This is x minus a whole to the power of n expansion. In this general term is given by, tr plus 1 is given by minus 1 to the power of r ncr x to the power of n minus r and a power r. This is the general term. Okay, general term. Okay, next now so in general you remember this one, x plus a whole to the power of n equal to, we can write like this, t1 plus t2 plus t3, all are positive terms only, t4 plus so on dash dash tn plus 1. There are n plus 1 terms. Am I correct now? Say equation 1. Okay, now x minus a whole to the power of n. So for example, if x plus a whole to the power of n is t1 plus t2 plus t3 plus t4 plus dash dash plus tn plus 1, then what will be the x minus a whole to the power of n? So this will be t1, see, alternative sign change, minus t2 plus t3 minus t4 and plus dash dash, this will be minus 1 to the power of n tn plus 1. That means depending upon the sign will be depending accordingly, n is even or odd. So sometimes actually here one important thing we can remember, x plus a whole to the power of n plus x minus a whole to the power of n. Now tell me, what do you get now? X plus a whole to the power of n plus x minus a whole to the power of n. So this we can remember like this. T2, T2 cancel, T4, T4 cancel. You will be getting T1 plus T1 is 2. 2T1, 2 common. You get T1 plus T3 plus T5 plus T7, all odd terms, dash dash. So for example, if you want to find out x plus a whole to the power of n minus x minus a whole to the power of n, this will be 2 times, what do you get now here? So T1 cancel, you will be getting T2 plus T4 plus T6 plus T8 and plus dash dash. So this is equation 3 and equation 4. Because sometimes why should we take this one means, right, see sometimes you may be asked to find this question, root 2 plus 1 whole to the power of 5 plus root 2 minus 1 whole to the power of 5. You check, this comes under this formula. Here how many terms? Actually total 6 terms. 6 terms means you get T1 plus T3 plus T5. 2 times T1 plus T3 plus T5. First term, third term, fifth term. You have to add and multiply. You get this value. So this will be very easy. Okay. So this kind of problems can be solved with the help of this one. Right. I think you got an idea. Everybody? Right. T0 does not exist. Okay. Instead of T1 I have taken, first term I have taken T1 only, not T0, T1 only, right? Yes, T1 is T1 plus 0, NC0 x to the power of n. Absolutely correct, Madhurima. Okay, Rohit Yadav, actually please stop. Let me concentrate on the concept first. Next, standard form of a binomial theorem. Binomial theorem. Standard form of a binomial theorem. What is the standard form of the binomial theorem? What is the standard form of the binomial theorem? Right. So that means if n is a positive integer, then this 1 plus x whole to the power of n is called standard form, equal to 1 plus nc1x plus nc2x square plus nc3x cube plus dash dash ncr x to the power of r plus dash dash plus ncn x to the power of n, or this can be written like this: 1 c0 plus c1x plus c2x square plus c3x cube plus cr x to the power of r plus dash dash cn x to the power of n. Here general term, in this general term is tr plus 1 can be taken, ncr x to the power of n r. This is the general term of this one. So this is called general term. Okay. Right now, next, let's discuss one more concept now. Multinomial, not binomial, multinomial theorem. Directly we'll write general term in that one, multinomial theorem. Okay. The general term the general term the general term in the expansion of x1 plus x2 plus so on dash dash plus xp, there are p terms, whole to the power of n is this n factorial by c, we'll write n1 factorial n1 factorial n1 factorial n2 factorial and dash dash np factorial x1 to the power of n1 into x to the power of n2 into dash dash xp to the power of np, where n1 plus n2 plus and so on dash dash np is equal to n, equal to the index of the multinomial. Right. So now we shall discuss next middle terms of x plus a whole to the power of n. Let's have a discussion on the middle terms of x plus a whole to the power of n. Right. So now middle terms of the x plus a whole to the power of n means here two cases we need to write. Case 1, if n is even, okay, there is only one middle term, that is middle term is equal to so middle term is n by 2 plus 1th term. That means n by 2 plus 1th term you need to find out. That will be the middle term. Next one is case 2. Case 2 means if n is odd, then there are two middle terms. What are they? Middle terms are n plus 1 by 2 and n plus 3 by 2 with the terms. Okay, so these are the formula. Actually we need to, if you want to find out middle terms, we shall make use of this concept. So this concept is enough. I will discuss in the problems. So now here see, the coefficient of the middle term is termed as known as the largest coefficient. That means the coefficient of the middle term is the largest coefficient in the expansion of x plus a whole to the power of n. If you are asked the largest coefficient means you need to find out here actually coefficient of the middle term. So next is largest coefficient. Largest coefficient of all the coefficients. Largest coefficient. Right. Okay. The coefficient of the coefficient of the middle term is the coefficient of the middle term is the largest binomial coefficient. Binomial coefficient in the expansion of x plus a whole to the power of n. X plus a whole to the power of n. Okay, next here, okay, if n is odd, there are two largest coefficients. In the expansion. Which are NC n minus 1 by 2, NC n minus 2, and NC n plus 1 by 2. Here one interesting fact is that both are equal. Okay. So this NC n minus 1 by 2 and NC n plus 1 by 2 both are equal. If even n is odd also, they are equal. Only largest coefficient will be NC n minus 1 by 2 or NC n plus 1 by 2. For example, if n is even, very simple this is, n is even, then there is only one largest coefficient, that is NC n by 2. That's all. NC n by 2. Okay. So now right. How to find x to the power of k coefficient in a times x to the power of p plus b upon x to the power of q whole to the power of n expansion. This is the question mark. This is very, very important. Coefficient of x to the power of k in the given expansion we need to find out. How to find out that one? Okay, let me explain this one. Right, definitely I will do it. So now see, let us say like this. Let comparing with the x plus a whole to the power of n, x for a times x to the power of p, a for b times x to the power of q. n for n only. Okay, comparing x plus a whole to the power of n. Let us say tr plus 1 be the term consisting of x to the power of k coefficient. That means first tr plus 1 write down. Tr plus 1 is equal to, ncr x to the power of n minus r and a to the power of r. So let us replace here x means this ax to the power of p, a means b by x to the power of q. ncr, this is ax to the power of p whole to the power of n minus r, b upon x to the power of q whole to the power of r. Okay, let us separate it now. This ncr a to the power of n minus r x to the power of p n or np minus pr into b to the power of r by x to the power of qr. This will be x to the power. Here bases are equal. This power should be subtracted from this power. This we can write ncr a to the power of n minus r, b to the power of r, x to the power of np minus pr. Okay, x to the power of np minus pr minus qr. So now what we need to find out now here, see, this must be equal to k. That means np minus pr minus qr equated to k. Bring k this side. np minus k equals to r common p plus q. So r equals to np minus k by p plus q. Okay, right? So that means using this is the shortcut. How to find out r value means very simple. Here see, I'll give the logic also. N multiplied by p and minus k, np minus k upon add these two, p plus q. So you get r value. After getting r value, the term will be decided. If you substitute r value here, this is the x to the power of k coefficient. Understood now? So in this way we can find out. In the problems we don't do this lengthy method. Simply we can make use of this formula. This is the shortcut formula. I derived the shortcut. How did you get the shortcut? For example, here independent term. So independent term means this k becomes 0. That means np by p plus q, r value will be to get independent term. Okay, let us discuss how to find out independent term. How to find independent term or constant term. Of a x to the power of p plus b upon x to the power of q raised to n. This is to find out. See, we know that actually x to the power of k coefficient is we can write now like this. R value is equal to np minus k by p plus q. Here for independent term or constant term, that will be, you can say, x to the power of 0. That implies k must be 0. So put k for 0. You get np by p plus q. This formula we need to use. If you know the r value, then we can determine the term r plus 1. You need to find out r plus 1 in this expansion. So that is the independent term. X to the power of x to the power of power becomes 0. That's okay. Yes, understood now. So next now we need to discuss about numerically greatest term. That's very important. Numerically greatest term. Numerically greatest term or terms, NGTs, numerically greatest terms. Numerically greatest terms. Right now. So how to find out the numerically greatest terms? See, numerically greatest term or terms in 1 plus x whole to the power of n. Actually, the numerically greatest term we can find out in standard form itself only. If it is not in the standard form, we need to put in the standard form. Understood now? So that's why the numerically greatest term in 1 plus x whole to the power of n, we need to find using two cases. First case, say A, first find this value, n plus 1 mod x you need to find out. Modulus of x means numerically greatest term means here sign is not criteria. By this we need to write mod x plus 1, value we need to find out. If it is something p plus f, where p is an integer and f stands for fraction and f is a fraction. F is a fraction means 0 less than f less than 1. It lies in between 0 and 1. Okay, then there exists only one NGT, numerically greatest term, that is TP. Understood now? Sorry. We need to add 1. TP plus 1 term. TP plus 1 term is the numerically greatest term. That we need to find out in the given this expansion. So next one is, if n plus 1 mod x upon mod x plus 1 equal to only p, fractional part is 0, where p is an integer there are two NGTs, two numerically greatest terms, that is TP and equal to TP plus 1. TP and TP plus 1. P plus 1 there will be, but both are equal. And pth term and p plus 1 term we need to find out. Right. Next, for example, how to find NGT or NGTs of x plus a whole to the power of n expansion. How to find out? So that means if and only if put this x plus a whole to the power of n. Mr. Rohit Yadav, how do you put this x plus a whole to the power of n in the form of 1 plus x whole to the power of n? Please chart on the box, chat box. You give your answer. Okay. See, if you want to find out here, what we need to do means x plus a whole to the power of n. You need to consider take a common in the bracket. If you take a common, you get 1 plus x upon a whole to the power of n. This equal to a to the power of n and 1 plus x by a whole to the power of n. Now it is in the form of a to the power of n into 1 plus x to the power of n form. For this one we can find out NGT. Then for this one we can find out NGT. Understood now? Right, next. Okay, first we shall have one discussion. A plus b whole square plus a minus b whole square. What is the value of this one? A plus b whole square and a minus b whole square. What do you get it now? What is the value of this one? Right, anybody? Right. This equals to a square plus 2ab plus b square plus a square minus 2ab plus b square. Am I correct now? So what happens means plus 2ab minus 2ab gets cancelled. Now we have this is 2 times a square plus b square. Now I shall ask one question. I shall ask you one question. How many terms are there? Otherwise you can write like this. The number of distinct terms in a plus b whole square plus a minus b whole square is, one question you are asked. First one, option 3, second option 1, third option 2, fourth option 1. So which is the right option actually? How many number of terms are there here? 1, 2. Option is 2. For example, this is actually power is very smaller. So directly by simplification we have written. One question is given like this. How to find out now? Here 2. With the help of 2 means how did you get 2 here? Any formulation? We need to check it now. See, one formula, important formula, we can discuss. The number of we can say distinct or non-zero. The number of non-zero, because 2ab becomes 0 here. Number of non-zero terms in x plus a whole to the power of n plus x minus a whole to the power of n is first point. If n is even, then number of terms is equal to, what is the formula? If n is even, is number of terms equals to n by 2 plus 1 terms. N by 2 plus 1. N by 2 plus 1. You see here actually 2 by 2 is 1, 1 plus 1 is 2. Second, if n is odd, suppose n is odd, then number of terms. So number of terms will be n plus 1 by 2 terms. N plus 1 by 2. You have n plus 1 by 2. So in the similar manner, we shall discuss the number of non-zero terms in x plus a whole to the power of n minus x minus a whole to the power of n. First point, if n is even, if n is even, okay, if n is even, then number of terms equal to n by 2 only, not n by 2 plus 1. Because if you check a plus b whole square minus of a minus b whole square, you get 4ab. Only one term you will get it. 2 by 2, 1. Understood now? Second concept in this one, if n is odd, then number of terms equal to n plus 1 by 2 only. N plus 1 by 2. This is n plus 1 by 2. So this you remember. Okay. One more important point you need to be discussed. The number of distinct terms or non-zero terms of x1 plus x2 plus x3 so on plus xr whole to the power of n is n plus r minus 1 c r minus 1. It's a combination formula you need to remember. This will be useful for even permutations and combinations also. The number of distinct terms of x1 plus x2 plus x3 plus so on xr, this is xr multinomial whole to the power of n is n plus r minus 1 c r minus 1. For example, one question let me discuss. The number of terms of, one example, the number of terms of x plus y plus z whole to the power of 10 is, what is the answer? Here see, in this case actually n equal to 10, 1, 2, 3, r equal to 3. So that means solution is C, number of terms is equal to 10 plus 3 n plus r minus 1 c r minus 1. R means 3 minus 1. This is equal to 13 minus 1, 12 c2. 12 c2 equals to, we can calculate like this, 12 c2 already discussed, 12 into 11 upon 2 into 1. This is 66. 66 terms are there. 12 c2. Understood now? So thank you. See you. Bye bye. So we shall meet you today only by actually 9 o'clock or 8:30, in between 9 o'clock, 9 to 10 we shall have the class. Otherwise, shall I take tomorrow? Okay. Tomorrow I will discuss rest of the direction cosines and direction ratios problem. Thank you. Bye bye.